video. Today we're looking at question 530, minimum absolute difference in BST. The way we'll be solving this problem is by using in-order traversal. And the reason why we'll be using in-order traversal is because even though we want the absolute minimum difference between any two values or nodes in the tree, the smallest difference will always be between the nodes that are right next to each other. And the reason why that is because, for example, if you go from 1 to 4, that difference is 3, right? So the distance between the nodes, as it increases, the difference between them also increases, because this is the binary search tree where the values on the left of a given node is less than that node, and the values that are on the right of the node are greater than the right node. So the values that are closest to a given node are on the left and the right. Therefore, the minimum difference will be between the nodes that are right next to each other. And to be able to keep a track of the nodes that are right next to each other, we can use in-order traversal. In-order traversal basically goes to the left node, looks at the root node, and then goes to the right node, and this keeps going recursively. So let's use this and get started. The first thing that we need are two global values, actually. So the first global value that we would need is like tree node previous. So basically the previous node that we've seen that we'll be comparing the current node to. The other would be the minimum difference that we've seen so far. These are the two global variables. We'll initialize them within the main method. So previous would be just null because it's not initialized or anything. We haven't seen anything previously, so just set that to null. And minimum difference, we just set that to the max value. So integer dot max value. And the reason why that is because anytime we compare two values, and because they have to be smaller, and we just need to compare it with this, and we use the math.minimum function, so it just takes a smaller value then. And anytime we set any sort of limits, we want to make sure that the range makes sense. So we know that the number of nodes in the tree would be in this range, but the value and the difference between those two nodes will always be within the integer ranges. So we should be good with this. The next step is basically creating the recursive function. Let's call it helper. We pass in the root. And once we have finished that recursive function, we just need to pass the minimum difference, which gets updated in the recursive function. So let's write the recursive function. We don't need to return anything because the value gets updated in place. We've called it helper, the name of the recursive function, and we are given one parameter, which is the node. So with every single recursive method, you always need a base condition, basically, which is a stopping condition. So if node is equal to null, you would just return it as is, right? If not, because we want to go in-order traversal, we want to explore the leftmost node, right? So we would call this recursively on node.left. And we actually, once we've called it recursively all the way to the left, then we get access to the actual node. Well, we always have access, but we have gone all the way left, and then now we want to start computing. So if previous is not equal to null, this is when we can compare, right? So if, and then if previous is not equal to null, you can compute the minimum value. So mat.minimum would be min.diff. So you're comparing the current value, and you're comparing the difference that we have between the previous node that we've seen, and then the current node, so node.value. Not value, but it's the difference between them, not that absolute. The difference here could be positive or negative, and because we know that difference is always going to be, so we always want to compare like the greater value to the lesser value. Not all the values will be positive. So that's the reason why we can just do the previous value, just compare it to the the node, the current node, and then like get the absolute value between them and assign that to minimum difference. Once that is done, we can set the previous node to be the current node because we're done analyzing the previous node, and then this is again recursively called on the right node. Awesome. So that is the entire problem. Let's try compiling this. The first few test cases are okay. Everything else is okay as well. Awesome. Let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we have to iterate through every single node that's given to us. The space complexity is of 1 because we're not necessarily using any additional space, but if you take into account all of the recursive calls that are stored in the stack, then it would be of n. Depends on how you see it. So it could be of 1 or of n. Yeah, so that's a problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. Thanks so much, and I'll see you folks soon. Peace.